my goodness. For the last time ever. I mean, maybe you'll have a university prof. No, you won't have a university prof that does that. Okay. So this is your last chance to say bye to Anne. The diagram below shows part of an electric circuit. There's some kind of a circuit junction. What is the current and its direction through the 5 ohm resistor? What? Oh, okay. I looked at this junction right here. This is coming in. I noticed that this is flowing out and this is flowing out. How many amps do I have flowing out? Well, 0.75 plus 0.53. I have 1.2 amps flowing out. If I have 1.28 amps flowing out, how many amps must I have flowing in? 1.28. It looks like right now I only have 0.96. So first of all, what's the direction? How would I describe this? I would say maybe if you put an arrow there, I would give you a mark. I would say down and right, or you could say towards the junction or inwards. And what's the magnitude? I guess the magnitude is going to be 1.28 minus 0.96, which is going to be 0.32? No. Is it? Yeah? It's a quiz, so I'll do it on a calculator just in case. 0.32 amps. So 1 mark for each of those. That's Kirchhoff's law for current. Current in has to equal current out to any junction. Number 2, 4 resistors and a 15 ohm power supply, 15 volt power supply are arranged to form a circuit shown in the diagram below. What's the total resistance of this circuit? Okay, first thing I'm going to do is I'm going to combine those two that are in parallel. So I'm going to say 1 over R parallel equals 1 over 10 plus 1 over 10. R parallel is 10 reciprocal button plus 10 reciprocal button 5. R parallel is 5. So R total is going to be, now these two can be replaced with a single 5 ohm resistor. So I can kind of imagine a 5 ohm, Mr. Duke, right there. So now I have a 20, a 5, and a 20 in series. Our total is going to be 20 plus 5 plus 20, 45 ohms. Is that correct? 3 marks if you got that. Otherwise, I would give you 1 mark if I saw that. 1 mark if I saw that you had added the remaining resistors in parallel that were, in series, and 1 mark for the answer. What's the total current leaving the battery? Well, I total equals V total over R total. R total is 45. I total is 15.33 amps. I would give you 1 mark for that, half mark for the numbers, half mark for the answers. If you got A wrong, but you went 15 divided by your answer from A, I would give you 2 out of 2 for part B. What is the voltage drop across R1? Oh, well, I guess it's going to be 0.33 amps going through R1. I'm going to go 15 divided by 45 so that I have the whole thing on my calculator. Times 20, 6.67 volts. V1 equals 0.33 times 20 equals 6.67 volts. I would give you 2 out of 2 for that. 1 mark for that, and 1 mark for the answer. Ooh, here's a terminal voltage question. This is the little internal resistance. A says, what's the terminal voltage of the cell? Well, label downhill. Try and find current. I don't see amps anywhere. Do I know two things? Do I know two things? Nope. Skiing, nope. I'm going to have to rewrite this. So the first thing that I'm going to do is I'm going to say 1 over R parallel is 1 over 10 plus 1 over 10. I just did that. I'm pretty sure that's 5 ohms. So I can replace this with a single 5 ohm resistor. So what that means is our total is 5 plus 0.7. It's 5.7 ohms. I total is going to be V total over R total. It's going to be 15. And remember, this is the symbol that we use for what's printed on the battery. It's the maximum theoretical voltage. This is constant. It doesn't change. What does change is your terminal voltage. I total is going to be 15 divided by 5.7. This is not going to be a nice number, I don't think. Yeah, I'll write 2.63, but I'll store it on my calculator. And so finally, the terminal voltage is going to be 15 minus what I lose going through the internal resistance, which is going to be I, 2.63, times R. 15 minus answer button times little r. And I get a terminal voltage of 13.2. I would take 13.1 as well. So we lose about 1.8 volts going through the battery. Suppose the bottom 10 ohm resistor is removed. The terminal voltage of the battery will increase, decrease. Well, so there's two ways I can do this. I can do this theoretically, intuitively. I can say if I remove a resistor in parallel, our total is actually going to increase, not decrease. And because our total increases, that means that I total will decrease because you're dividing by a bigger number. And that means that I times little r, the voltage drop, will not increase, it'll decrease. The voltage drop going through the battery will decrease. And so you're going to get the terminal voltage will actually go up. Instead of 13.2, it might be 13.5. Well, you know what? Or I could actually crunch it, because if I remove one of the 10s, our total, instead of 5.7, it's going to be 10.7 ohms, because now I would just have this and this in series. And so I total would be 15 divided by 10.7, 1.4 amps. And so I times R, little r, would be 1.4 times 0.7, 0.98. And so the terminal voltage is going to be 15 minus 0.98, which I'm pretty sure is 14.02 volts. So instead of 13.2, we got basically 14 volts. So increase or decrease? 1 mark if you circled increase. And then if you solved it, I would give you 2 out of 2. Or if you said something like that, I would give you 2 out of 2. Number 4. What's the power dissipated in the 16 ohm resistor? Alrighty. First thing I'm going to have to do, well, label downhill. Don't see amps, don't see amps, don't see amps anywhere. I don't know 2 things, I don't know 2 things, I don't know 2 things, I don't know 2 things. Skiing doesn't help. I'm going to have to rewrite this. I'm going to combine these two. So I'm going to have 1 over R parallel is 1 over 16 plus 1 over 25. R parallel ends up being reciprocal of that. Yuck. Well, there's a 0 there. 9.756, is that right? Okay. 9.7561 ohms. So really now this circuit becomes a 15-volt battery, a 7 ohm resistor, a 9.7561 ohm resistor, and a little 1 ohm resistor, and that's the internal resistor. So now our total is going to be 1 plus 7 plus 9.7561. Our total is going to be 1 plus 7 plus answer button, 17.7561. Alrighty. I total is going to be V total over R total. Not I total, Mr. Duick. R total. It's going to be 15 divided by 17.7561. 15 divided by answer button. And I get 0.84478. Amps. Alrighty, what do they want me to find? The power dissipated in the 16. So I got to keep going here. Well, that means that this is 0.84478, and this is 0.84478. I'm going to really look at this right here. This is also 0.84478 amps, and I should put the units there. Because here, I know two things. I can find the voltage drop. The voltage drop is going to be that times 9.7561. Not very nice numbers, but such is life. The voltage drop going through there is going to be 8.24176. 8.24176 volts. And what that means is up here, the voltage drop is going to be 8.24176 volts. And in here, it's going to be the same. But I don't care because now I know two things. That's enough. Power is also V squared over R. It's going to be 8.24176, and I lifted that right from the formula sheet. The one we used the most often was V times I, but there was others. Divided by, and R was 16. Don't forget the squared, Mr. Duick. So it's going to be this number squared divided by 16. Whew. And I get 4.2, maybe 4.3, depending on how you round it off along the way. 4.2 watts. Is that right? I think that's right. If you got that, 7 out of 7. Otherwise, how would I give out part marks? I would definitely give 1 mark if I saw R parallel. I would give 1 mark if I saw R total. I would give 1 mark if I saw V total. There's 3. I would give 1 mark if I saw somewhere that you had calculated this voltage. That's 4. I would give you 1 mark if I saw that you'd clued in that it also went on there. That's 5. I would probably give you 1 mark if I saw a power equation and 1 mark for the answer. Probably something like that. That's a fairly challenging one. I would consider that along the upper level of difficulty of what I'm going to be throwing at you. But it is fair game. So if you got it right, good for you. Can you give yourself a lovely score out of 23, please?